Circle intersection. Given two congruent circles A and B of radius r, return the area of their intersection rounded down to the nearest integer. Okay, pretty easy sounding. Less than 94 characters. That sounds like not very much. Okay, difficult. Let's give it a go. I'll make this big. Right. So, where to start? So, I'm thinking, let me just get paint. I'm thinking we're gonna potentially have, wait, what's the input then? Instructions, right? So, okay, so circle 1, circle 2, they're arrays indicating coordinates. So they may or may not overlap potentially if they're on some kind of two-dimensional plane, depending on the radius and their position. So, okay, I think I have an approach in mind. So if we imagine two circles, congruent ones, which is just that they're the same size and shape, we could have something like that, let's say. And what we're being asked to measure is this area here. And if I take a line between the centers, I think this line is a crucial line that we need to calculate, which will be based upon, say, these coordinates. So we're going to have a coordinate here. I'm going to extend the lines, and a coordinate here to define the centers of the circles. Coordinate, coordinate. But if you can see that here, let's choose a new color. We're going to need to calculate the position of this chord. Now I'm just going to get up the formula for area of a segment, I think. Area of a segment. 1 second. Yeah. Segment of a circle. Okay, my PC's lagging. Area of a segment. A minor segment. Let's just get to the punchline. So it's half of a half times the radius times, okay, this is in degrees, pi times theta over 180 minus sine of theta in degrees, yeah. Yeah, this is in radians. Half of r squared times theta minus the sine of theta. So the key things we need to know are this angle, actually, and the radius. And that defines the segment. Yeah, that makes sense. So here then, once we have this length, well, the full length, we can halve it to get the length here, which, if I'm not mistaken, this length only is will give us the angle. So if we do the inverse, what is it, cosine of this as a proportion of r, that will give us some value between 0 and 1, which will be the cosine of this angle. So if we do the arc sine of this distance, that will give us the angle. Then once we have the angle, we'll have the radius of the circle. We can double the angle to get the total internal angle of the segment, not sector, I keep confusing them. And based on that, we can calculate this segment and double it to get the area of the intersection. We have a plan. Right, let's get rid of that and just write some code. So first thing to note is A and B are actually arrays. Therefore, we probably should just destructure these to get the actual numbers for each of the x and y coordinates. So we can have that, and we'll just say A and B, C and D, let's say. And we can do, so to calculate the distance between the centers, if I bring this back, what we need is the deflection in the x and the y axis. So this distance, oh, I should have picked a different color. This distance and this distance. Based on these, we can calculate this distance. Just using Pythagoras theorem. So we need the difference between the x coordinate of both circle centers and the difference between the y coordinate of the circle centers. So we can do that here. Const dy equals, well, let's do dx first, equals a minus c. Const dy, and I'm for the moment going to completely ignore the word count. I'm probably already in excess of it, I think. We can try and condense it down after. B minus D. Okay. Then we can do Pythagoras. Now, I happen to know there is a function on the math object for calculating the hypotenuse of a triangle, given some inputs. So we can say h for the hypotenuse, which is this length, this diagonal length, is equal to math.hypot, and we can specify dx and dy, and that will give us the hypotenuse. Just wondering whether we want to halve it, because the actual value that we really want is this line here. So we'll halve it. And when I'm saying up to this orange line here, so I'm cutting it in half. Cool. Next. Well, we want that as a proportion of the radius. So you'll see from the center to this orange line here is less than the distance between here and the radius. So if we take this smaller portion and divide by the radius, that's going to give this distance as a proportion of the distance to the radius, which will be a value between 0 and 1. Which again, I guess we could capture here. Do we want it here? I'm not sure, but I'll do it here for now, because now what we can do is we can calculate this. Pick a new color. Oops. We can calculate this angle based on having this, essentially the cosine there. So if we do const t, I suppose, for theta, which I think is what that symbol is. Let's quickly Google it. Theta. Yeah, cool. T equals math.arc sine a sin. Yeah, it's a sin, I think. asyn of h will give us an angle. So maybe we should just see how we're doing. Console log t, and our first example here starts at 0, 0 and 7, 0, so it is deflected in the x-axis by 7 units, and the radius is 5, which means imagine these are along a horizontal axis. Well, I suppose we can just draw it quickly. Radius between here and here is 5. This is not to scale, and there is 5. So you can see if they were touching like that, let's say, God, that's a terrible drawing. The distance between their centers would be 10. There to there. So we're expecting that h will be something like, well, it will be 7 actually. 7 exactly, and t for theta will be something like well, it'd be less than that, maybe like 30 degrees or something. In fact, it might even be exactly 30 degrees, because yeah, I don't know, just got a gut feel. I happen to know that the sine of 30 degrees, sorry, the cosine of, anyway, yeah, I don't know. Let's see. Let's log all that stuff out. Where does that go? I'm zoomed in, maybe that's okay. 0.7. And of course, degrees. Yeah, the trigonometric functions in JavaScript by default use radians rather than degrees. So I wonder what that is in degrees. Radians to degrees. Okay, so 44 degrees. Okay, which is roughly in the area of where we think it should be. Based on the diagram that we drew over here, that's about 40 degrees. Okay, so I think we're roughly on track here. Let's keep going. I suppose I can just delete the logs. So we now have theta, but we actually want to double it because the internal angle specified by this formula is, if you imagine that rotated 90 degrees, we've actually just calculated half of this. So we want to double it to get the full internal angle for that sector, so that we can calculate the segment using that formula. So cool. So we want t times 2. Yeah, that makes sense. And then, well, I'm just going to copy this formula over, basically. Area equals half of r squared times theta minus sine of theta. So const, we've used a, so let's go, I don't know, r for, oh, we've got r, I was going to say r for result, but s for solution equals 0.5 times r squared, r to the power 2, times, open bracket, close bracket, t for theta minus math.sin of theta. And then, in theory, we can return s, and that'll be the solution. I have the feeling, though, the hard bit is just about to start. What's wrong with that? Oh, I've used an x. Like a fool. Okay. Ah, yes. Okay, so I've actually just calculated the area of a single segment. My bad. So actually, we need to multiply this by 2 to get 2 segments. So here, I've only calculated, this and this, but we want to include the green as well. So we double it. And in theory, then, that should be the correct area. It's still failing. Right. Expected this. So that looks roughly correct. There's some rounding involved, I think. Rounded down to the nearest integer, which is a little worrying. Because if I do math.floor on this, then it's going to be 13, which is wrong. So what have I done wrong? Math.hypot dx dy divided by 2. Maybe I'll just put that there. That shouldn't matter though. Yeah. Okay. Sine of theta. Let me just get that again. Maybe I've made some mistake. Oh, did I do minus? Yeah, t minus sine of theta. Half times multiplied by that. Well, the 2 and the 0.5 cancel, so that's fine. But again, that shouldn't impact anything. A is x, b minus d. Okay. 1.55. It's console log of h. H should be 3.5. 3.5, yeah. Arc sine of 3.5 divided by 5. Oh, 3 over 5. No, 3.5 over 5, so that's fine. 3.5 over 5 is... Ah! I know what it is. Yeah, I'm doing the sine. I should be doing the cos. Yeah, cosine is the deflection in the x. Yeah, that's the reason. That's the reason. Test. Okay, well, we've got a lot more output, which actually is good. We've got 14 here, which is correct. Yeah, and this has moved on to the next test, so it's passed that test. Right, so we can kill that one. Kill that one, kill that log. And let's test it again. Cool. Right. So in one case, you got not a number. So that's fine. So I think that is the scenario where we are outside the valid range for the arc cosine. So as I mentioned before, you have to have a number between 0 and 1. Now, if the hypotenuse here, for example, if we had two circles, let me just make some space. If we had some circles that were not intersecting like this, we'd have a hypotenuse here, which is very large in comparison to the radius. But we're assuming here that the hypotenuse is less than r. So if this was like 10 and this was 5, then we'd end up with a value of 2, which is not actually valid for the arc cosine. So what we can do here is do math dot what am I trying to do? Oh yeah, min, take the minimum value of either this or 1. So if this exceeds 1, then we're just going to cap the value at 1. So we'll test that. Well, hey, and it passes all of the tests. Now this is quite long and quite verbose, which I think means our attempt is going to fail because we should be less than 94 characters, which is, I think, where the challenge is about to begin. What is our length? 204. So we're over 100 characters too long. But we can clean a lot of this up, I think. So we don't actually need to store these. We can do this, this. H is only used once, therefore we can put that here. Let's just put brackets around it. Although actually I don't think it's needed. You can do that. Let's just run it again, make sure it still passes. Which it does. Then we have T. Now T in the formula for the area of a segment is used twice, and I don't think there's any way that this can be simplified because you've got one inside a sine function and one that is not. Therefore, I think we don't have any option but to keep some reference to T, although it doesn't have to be a constant. We can just declare it on the fly here. Similarly here, we can get rid of the const keyword. Not that that's good practice, but to solve the challenge. Well, let's see how close we are now. There's still a lot of optimizing we can do. 146, okay. So we're getting there. Ah, spaces, white space. We can get rid of all the white space. Here, 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 here. In fact, all of this. Well, here's a crazy idea. Rather than actually have the new line characters, we can declare these as arguments. It gets a bit long. I'll tell you what, I'll leave that for now. One clear thing we can do is this math object we're reusing multiple times. So let's do m equals math and shorten it and change all of these to m. Previously we were 146, and what are we now? Oops, wrong button. Oh, what have I done? my bad. Attempt 146, and now we are 126. Okay, that was a good saving. Right then, what else can we do? Well, assigning this variable is not needed either, so we can actually get rid of this whole line, stick that in there. So we'll go from 126 to 122. Okay. Wow, this is getting challenging. Well, ideally, I don't want this return keyword. So maybe to get rid of the return keyword, it actually is beneficial to put this as an argument here. So it's just an optional parameter that we're just assigning a default value. Just zoom out a little bit. Oh, that wasn't good. That's not good either. Yeah, I'm a bit too zoomed in. Right. So now I can get rid of the return statement and the bracket. So we're now genuinely on one line. This doesn't have word wrapping, which is a bit frustrating. Cool. So how long is that? I'll just click the attempt button. 111. We've still got some way to go then. Floor. There's a way using there's like a bitwise operation for taking the integer that I've seen before. Let me just quickly see if I can find it. Yeah, here it is. As in the examples, the functionality if tilde and math.floor are the same, but both of them round to a number. Yeah. Yeah. Oh, that's weird. Now I've got a feeling you can kind of substitute tilde for a floor in some cases. So let's give that a try. Attempt. Well, it passes all the tests. So we just need to get rid of 12 more characters. Can't see much that we can do, to be honest. I think you can use a bitwise OR. slightly shorter. Yeah. Ooh, interesting. If we're using this OR, I think if this evaluates to an error, then it will assume 0, which means this min may be redundant now. Because if this, say this evaluates to a number that, because of the hypotenuse being long, and it's a number that's greater than 1, then this will error with not a number, which is correct. This will then error with not a number. All of this will resolve to not a number. And I think the behavior of this bitwise OR will then return this 0, which is correct because the hypotenuse is long and there's no intersection. So the answer is 0. So I think we can do this. Delete that bracket and that bracket. Let's just run a test. Ooh. Well, why did that do that then? Or unless I've removed the bracket from the wrong place. Oh, I kept the 1. Did I keep the 1? I think maybe I kept the 1. Yeah. Oh, 95. We need to get rid of one more character. Circle intersection. T. Huh. Yes. This could be R times R. Oh, it's still not long enough. Code length is, it's got to be less than 94. Oh, man. Okay. Now, if I remember correctly, when you assign a variable, it returns the value of the thing that was assigned. So if I was to do this assignment actually here, let's say, let's put in brackets. I think the bracketed section will resolve to there probably, isn't it? will resolve to the value of this, which is what is being assigned, and it will assign to the value t. Now I think I just made it longer though, so that might not help us. Oh, it's the same length. Okay, well that is maybe cooler. Be good if we didn't need these brackets. But we... Wait, do we need those brackets? Apparently, yes. But we wouldn't need those brackets if we were inside here. And that would save us some brackets. However, the way it's evaluated is a problem, because if we just had t and then do that, it evaluates the expression from left to right, so t isn't assigned at this point. T is not defined, but maybe if we, if we take this and put it first, and plus t. So wait, if you have t minus some value, yeah, that is correct, I think. So then we're doing some value minus the sign of that value plus t, which is now assigned. Oh yes, correctamundo. Nice. Well, that was a lot harder than I expected it to be. And there you go, there's the final solution then. We assign the math object to m to make it a shorter alias. We do r squared by r times r, which is slightly shorter. Take the sign of this variable assignment, and that's basically the guts of the formula, plus the t that we've assigned. If it's an error, then return 0. And that also doubles up as the thing that is like a bitwise, that is truncating the decimal place. So epic. I like that one. So if you have any particular questions that you want me to look at, I'm always looking for, any input, any ones that are particularly interesting. Yeah, I'd love to rip into anything that you guys like. So let me know.